Hi there, Falcons. Welcome to another DI or direct instruction video on fluids. Hmm. What comes to mind when you think about fluids? Maybe what? Yes. You might think, oh, maybe it's a gas, maybe it's a liquid. Basically, you think about the states of matter, right? So, the states of matter, commonly we have the three popular states of matter: solid, liquid, and a gas. But when you were in grade 7, you also took up the idea of plasma and the BECS, or the Bose-Einstein condensates. So I hope you can still remember them. So last time we said if plasmas are super hot and super excited atoms, the atoms in a Bose-Einstein condensate are total opposites. They are super unexcited and super cold atoms. Okay? But our concentration now would be on the fluids. And with liquids, it is clear that all liquids, listen, all liquids are fluids, but not all fluids are liquids because fluids also contain substances in the gaseous state. Now, basically, a fluid then is they must have particles that can easily flow past each other and take the shape of its container. So it can be liquids and gases. Now, a fluid is anything, a substance that flows. So examples would be honey, water, and lava. They are all fluids, but so are gases such as oxygen and carbon dioxide. And we use fluids to help us improve our lives. Now, everything boils down again to the particle theory of matter. This actually helps explain why fluids act the way they do. It states that all matter is made up of tiny particles. Particles have empty spaces between them. Particles are moving randomly all the time. Particles move faster and spread farther apart when they are heated. And particles attract each other. Now, here's another idea that you could just imagine in your head: a river flowing down a mountain, air passing over a bird's wing, blood moving through a circulatory system, fuel moving through an engine. These are all examples of fluid flow. So, a fluid is a substance that conforms to the shape of whatever vessel or container that it is in. Now, there are many uses of fluids. That's why it is really one big learning unit for grade 8 science learning. So fluids can transport solids. A mixture of water and solids is called a slurry. The paper that you write on, consider that, was once a slurry of wood pulp and water. Hydroseeding is the process of spraying a slurry of seeds, fertilizer, and sawdust to plant difficult to reach areas. Okay. Now, fluids can hold other materials also. For example, the cytoplasm in your cells uh, hold the organelles that allow a cell to grow and replicate. Toothpaste is a fluid that holds materials designed to clean, polish, and protect your teeth. Okay. Now, a slurry of water and cement is easy to transport. As it hardens, it can be shaped to become a smooth, level concrete sidewalk. Now, each of these photographs show fluids in use. Essential questions would be: how are our lives improved by each of the uses shown? What environmental issues are raised by its use? Two questions to think about. Now, characteristics of fluids. Remember, one, all fluids exert pressure. All fluids exert pressure equally in every direction. Now, more on the idea of pressure. So, pressure refers to the amount of force exerted on a given area. Mathematically, this is represented by the formula: pressure equals force over area. Now, the scientific unit for pressure is the Pascal, and we usually represent it with a capital letter P, small letter A. Now, water pressure, right? So, water and other liquids are more dense than air or other gases and exert more pressure. The pressure exerted by water depends only on the depth. The deeper you go, the more pressures there will be. Second characteristic of fluids. Fluids always flow from high to low pressure. When you inhale, like that, and your lungs expand, the pressure inside your lungs decreases, allowing air to flow from the higher pressure area outside of your body into your lungs. Now, there's a, what we call a principle in science related to fluids. It's called the Pascal's principle. So Blaise Pascal was a French scientist and mathematician who studied fluids in motion. So the study of fluids in motion, it's called hydrodynamics. Now, one of his findings was that a change in pressure at any point in an enclosed fluid will be transmitted equally to all parts of the fluid. This is called Pascal's principle. Now, another part of Pascal's principle would be the idea of hydraulic devices, which use liquids to transmit pressure from one point to another. The brakes in a car use a hydraulic device to transmit the pressure from the brake pedal to the brake pads on each wheel. Now, the idea of buoyant force. Pressure itself is not a force, it only describes the amount of some type of force acting on a given area. So when we want to talk about the force that fluids exert, it is called buoyant force. Buoyant force is an upward force. Remember that. Buoyant force is an upward force. Now, water exerts pressure on all sides of an object. Pressure exerted horizontally, this way, is equal and balance each other out. This, this one, okay? Because pressure increases with depth, there will be more pressure on the bottom, right, of the object. This creates the unbalanced upward force known as the buoyant force. Now, another principle related to the study of fluids would be Archimedes' principle. A Greek mathematician named Archimedes is credited with discovering how to measure buoyant force. It's a pretty crazy story, and I can just click this at some point and uh, let's see what I have here. So it's a YouTube video clip, right? Okay. So let me just stop that and let's go back to this. Okay. So with that short clip, Archimedes' principle says that the buoyant force of an object in a fluid is equal to the weight of the volume of the fluid that the object displaces. When we say displace, takes the place of. Now see if this helps. Another short video clip. So around 2 minutes. Okay.
What I'm going to do.
Let's watch.
What I hope to do is I'm going to dunk this in the water. And when I do that, this weight reading will go down, yeah? I mean, I can kind of show you over here. The weight reading does go down. Would you say this, that loss of weight was equal to the support force? And that support force, we have a name for it, begins with BF. Buoyant force, okay? So the buoyant force can be seen by the loss of weight. Can't read that now, but read it now. Read it now, subtract the two, there's a buoyant force, yeah? All right. I'm going to do it over here in this overflow can. But I'm going to catch the water that's displaced. And I'm going to weigh it. Whoops. This is not going to be perfectly accurate, okay? But note now what the reading is of just holding, it looks like a little bit more than 1 Newton holding up the empty cup. Now, I dunk this in. This is losing weight, yeah? It's because I'm displacing more and more water. There, now this has lost all the weight it can lose. This is still catching water. I want you to compare how much weight did this lose, the suspended weight, and how much weight did this gain? Do you see that they're the same? And that...
So I hope you got the idea. If you bring in any object, that part, that amount that overflows is the amount that's being displaced. Okay. Now, moving on. Now, density, the idea of density here is always associated again with fluids, just like when we have our unit on the water systems, right? So the amount of mass contained in a given volume is called density. Remember, we even had that problem solving on D equals M over V. So density describes how closely packed together the particles are in a substance. A substance is most dense when it is a solid, when it sinks, right? And the least dense when it is a gas or something that floats. So what sinks and what floats is credited to its density. Now, as I've said earlier, density is measure of volume, and water has a density of about 1 gram per cm cube. Cm cube, cubic centimeter is the same as saying 1 gram per ml. Now, objects with a density greater than 1 will sink. I hope you still remember that from our unit on the water systems or on the subject of density. Now, the overall density of an object can be changed by changing the shape of the object to create more or less volume. Now, remember, weight is the gravitational force acting on the object. Objects sink if their weight is greater than the weight of the fluid displaced. If an object weighs the same as the weight of the displaced fluid, the object will float within the water. So an object will float at the surface of the fluid if the buoyant force is greater than the object's weight. Okay. Now, also, this is a good essential question. If metal has a greater density than water, how is it possible for metal boats to float on water? Hmm, good question. Now, there's always this connection between density and buoyancy. Buoyancy, the tendency of an object in a fluid to rise or sink due to density differences with its surroundings. Now, how about the effect of temperature, right? Now, this brings in the idea of thick fluids or thin fluids. And that's all about viscosity. It is the resistance of a fluid to flow. So thickness or thinness of a fluid is called viscosity. Fluids with a high viscosity do not flow as easily as fluids with a low viscosity, right? So example here that I've included would be ketchup, right? It flows slowly. So we can say it's a thick fluid. Unlike water, the idea or concept of water is that it flows naturally, right? There's the smoothness of the flow. Now, temperature can have a big effect on viscosity. When heat is added to a liquid, the particles move faster and move farther apart. This allows the particles to move pass each other more freely. As the temperature of a liquid increases, its viscosity decreases. Now, the cooler the liquid, the slower it flows. So, a good analogy to this would be honey, for instance, right? If left on the counter for too long, it kind of becomes more solid in a sense. Like it's difficult to let it uh, flow out, right? So even on my end, what I do is I would put it in the microwave for maybe 3 or 5 seconds, and of course, temperature, you know, have a big effect. And I'm adding heat to it, right? So it makes the particles move faster. So honey moves faster now. Okay. So another thing that we have to contend with when we are talking about fluids in general would be the idea of a friction. Friction is a force that works to slow down motion as a result of surfaces rubbing against each other. The greater the rubbing, this way, or friction between particles in any fluid, the higher the viscosity. But in gases, the higher the temperature, the higher the friction, and the higher the viscosity. The warmer the gas, the slower it flows. So, as the water of the gas decreases, the particles slow down and collide less often, so there's less friction. The viscosity decreases. Remember, the cooler the gas, the faster it flows. Now, viscosity and flow rate. The flow rate of a fluid is a measure of speed at which a fluid flows from one point to another. The greater the viscosity, the lower the flow rate. Think of viscosity in terms of the fluid being thick or thin. So thick like maple syrup, honey, ketchup, right? The lower the flow rate. That's it for now. So I hope, um, Falcons, you had a good intro now on what is fluid, what is a fluid, or what is this unit all about. Okay, so that's it for now. Thanks for listening. Ciao for now.